This is a starting date of matter and radiation, the last lesson of syllabus. So in matter and radiation, we discuss about both materials and the interaction between materials and radiations. Radiations means simply electromagnetic waves. But basically here we learn about electromagnetic waves which transfer heat energy. Electromagnetic waves which transfer heat energy are known as thermal radiation. So basically we have we focus to the thermal radiations, right? So under this lesson, don't write anything, just look at both. We learn about several things. We learn about X-rays. Then we learn about alpha, beta, gamma rays. Then we learn about nuclear reactions. It means in that case we learn about half-life and some nuclear reactions. Then we learn about photoelectric effect. It's a very interesting part, photoelectric effect. And finally, we learn about black body radiation. So those are the things that we are going to learn in this lesson. Right. Please try the heading as matter and radiation. Please write these things. So once we learn about these things, actually you can consider that the lesson is over. Write them. So this is the first day, right? We didn't write anything than this. We have not written anything than this. Okay, dear. We have just started the lesson, a brand new lesson. Right. This lesson can be started at any section. If I want, I can start from. If I want, I can start from X-rays or alpha beta gamma rays or half-life or nuclear reactions, anything. I would like to start from X-rays. I'd like to start from X-rays. So please write the next subheading, X-rays. X-rays. Please write your first subheading as X-rays. We have not written anything earlier. All the things that we have written for this lesson are on the board. A brand new lesson. Be happy. X-rays. Right. And that please write, when fast moving electrons collide with a metal, when fast moving electrons collide with a metal, when fast moving electrons collide with a metal, comma, certain kind of electromagnetic waves, a certain kind of electromagnetic waves are emitted from the metal. A certain kind of electromagnetic waves are emitted from the metal. A certain kind of electromagnetic waves are emitted from the metal. Full stop. Full stop. Those waves are said to be, those waves are defined as X-rays. A certain, when fast moving electrons collide with a metal, comma, some kind of electromagnetic waves are emitted by the metal. Those electromagnetic waves are known as, or those waves are defined as X-rays. X-rays. Okay, dear. Would like if I repeat the note? Anybody in the class?
Sir, can you repeat the last line, sir?
Yeah, those electromagnetic waves are defined as X-rays. X-rays. Okay, dear. Lamai?
Yes, sir.
Yeah. Right. So we want fast moving electrons. And those electrons should collide with the metal. Therefore, we want a metal also. So what are the main two things? Let's say I want to make X-rays. I want to produce X-rays. So what are the things I want? I want electrons. There must be a source to generate electrons. And there must be a method to move the electron fast. And there is a metal on which the electrons collide or landed. So once the electron hit on the metal surface with a larger speed, some kind of an electromagnetic waves are released from the metal. Those electromagnetic waves are said to be X-rays. So what are the things that we want? A source which generate electrons. Then a mechanism to move the electron fast. Then a piece of metal. And the other thing, in mechanics lesson we have learned, when something moving faster, when it collides with an object, the kinetic energy of the moving object converted into some other forms of energy, such as sound energy, heat energy, sometimes even light. So in this case, when the fast moving electrons collide with the metal, huge amount of heat energy is generated. Huge amount of heat energy is generated. Therefore, the metal will be highly heated. Sometimes the temperature of the metal reaches to its melting point. Therefore, that's a possibility for the metal to be melted, to be destroyed. Therefore, we must have a method to reduce the temperature of the metal on which the electrons collide. Right. So what are the things we want? Let's say now we are going to make the X-ray tube. So we need a mechanism to make electrons. So we use a heating coil. So the theory that we use for this is said to be Bremsstrahlung effect. What is it called here? This effect, this method that I'm going to use is said to be Bremsstrahlung effect. I'll give you the spellings. So this is a heating coil. Heating coil. A heating coil. Right? You use heating coils in
Excuse me,
electric
sir.
kettles, immersion heat in your iron. So this is a heating coil. To generate heat energy, from a heating coil, we should provide electric current. To provide an electric current, I use a battery here, or I use a DC voltage source. The provided voltage is said to be, let's say, E1 volt. E1 volt. So E1 is the voltage source. It provides electricity. E1 volts. Got it? Then the heat energy generated by it incident on a piece of metal. This is a piece of metal. It is connected like this. A metal. Normally, right, when heat energy, so heat energy is generated by the coil is incident on this metal. Then electrons are removed from this metal. Electrons are removed. So these are free electrons given out by this heating coil due to the heat energy generated by the heating coil. Electrons are emitted from this metal. Those electrons are free to move anywhere. Initially, their velocity is 0. So these are free electrons. Free electrons. Right. There is the metal. This is said to be the target metal. Electrons should collide on it. So this is the target metal. This is the target metal. Okay. So electrons should move from this place to this place. Can you give me a method to move the electrons? Let me mark this point. Let me use the letter simple A. Give me a method to move the electrons from simple A to simple B. Somebody unmute the mic and tell me a method that can be used to move the electrons from here to here. They are initially at rest. Unmute the mic and tell me. I'll not teach anything until you tell me. And this is not a
Positively
complete
charging
diagram.
the target metal.
Draw it now, you will in a big trouble if you draw it now. So what should I do to move electrons from simple A to simple B? Somebody?
What? Positively charging the target metal. Positively charging the target.
Yes, Ahas, very
metal.
good. The target metal should be positively charged. But how can we do it? How can we do it?
By fixing to the circuits, sir.
By fixing into a circuit. What kind of a circuit, dear?
Sir, by grounding the metal.
By if we ground the metal, then
Grounding.
the potential of the metal will be 0.
The metal.
Electrons are negative charges. If you are able to make the target metal positive, negative positive attract, so electrons will collide. Electrons will move towards the positive charge plate. We are okay up to that point. Now my question is, how do we make the target metal positive? What should we do to make it positive, dear? Think.
Sir, by fixing that target metal into the circuits, sir.
What kind of a circuit? You are right. We should connect to a circuit, but what you should tell me what the circuit is. What is the simplest arrangement of such a circuit? Give me a method. I will not teach even a single sentence if you don't give me a method. You know my nature, right? Damidu, think dear. I want to make the target metal positively charged. So what should we do? Try again, I didn't hear you.
Connect a Wheatstone bridge.
Connect to a Wheatstone bridge.
A Wheatstone bridge.
No, we don't want such a complex circuit. By doing a very simple thing, we can make the target metal to be a positively charged. No
The
need
meter
such a
bridge,
complex.
or we should connect the target. We should
Yes,
connect the
Sadrushika, try again.
target metal parallelly.
Sadrushika, please try again.
We should connect the target metal parallelly, sir.
Target metal parallel to what? Parallel to what, dear?
Parallel to the battery.
Yes, very good. We should connect a battery to target metal. If I want to make this positive, what should I do? Just take the battery up. You think too much. That's why you are not getting an answer. There are very simple solutions. We should start with the simplest method, dear. After that, we can develop it. We can make it to a very complex arrangement. But starting thing should be very simple. If I want to make this positive, what should I do? Just connect a battery. Just connect a battery. Take a battery like this. Connect the positive terminal of the battery to this target metal. Yeah. But if you just connect, but the problem here is if you connect only the positive terminal, this will not be charged positively. So we do something like this. We connect the positive terminal of the battery. We connect the negative terminal like this actually. Wait. So negative terminal is connected to here. And wait. Let me change the arrangement slightly. And this metal, this piece of metal is connected to the negative terminal. So 3 points are connected like this. Right? Now somebody please tell me what is the potential of the metal simple A? What is the potential of metal simple A? Somebody please tell me what is the potential of the metal simple A?
It's 0.
Not yet. It is connected to the negative terminal. Therefore, what is the potential here? Negative terminal of a battery is connected to the metal simple A. Therefore, metal simple A should be in somebody?
Negative form.
It should be in a minus voltage, negative voltage. Why not? Positive terminal of the battery is connected to simple B metal. So what is its potential there? Positive or negative?
Positive.
Positive. So negative electrons pushed away by the negatively charged plate simple A. Negative electrons are attracted to the positively charged metal B. Therefore, electrons will be pushed away from A, attracted to B. Therefore, all the electrons will flow towards the target metal according to this arrangement. Can you understand it, dear? Is it clear or not? Lamai? You have to tell me at least yes.
It's clear, sir.
No. Is it clear or not?
It's clear, sir.
If you say not clear, will I get angry? You say, I explained everything properly, nicely. Then you say, no, sir, I didn't understand. Will I get angry? No, never. If you say you can't understand from this method, I'll use another method to explain. Got it? Once I explain two, when you say you can't understand, I'll use a third method and explain. I will never get angry if you say, no, I didn't understand. But you must say no. You must talk to me. That's the point. Right. Then then let's say I'll take one electron. Let's say velocity of this electron is 0 meter per second. When the same electron reaches to B, let's say velocity is v meter per second. So what is the starting velocity of the electron here? What is the starting velocity of the electron? U meter per second, it is 0. Ending velocity, v meter per second. If v is larger, the electrons will have larger amount of kinetic energy. So when an electron hits the target metal with a larger kinetic energy, it will generate very strong X-rays. So we want very strong X-rays. Therefore, kinetic energy of the electron should not be wasted. Kinetic energy of the electron should not be wasted. If air particles are there, when the electrons are moving, the electrons will collide with the air particles and kinetic energy will be wasted. If there are air particles, when the electrons are moving, they collide with the air particles and the kinetic energy will be wasted. Therefore, we kept this arrangement in a vacuum. To create a vacuum, we do something like this. We do something like this. We kept this whole arrangement. We kept the whole arrangement in a glass tube. The whole arrangement is kept in a glass tube. Actually, it's very ugly if I do it like that. So where can I complete the glass tube? Everything is kept in a glass tube like this. And there are no particles inside the glass tube. So this is a glass tube. Nothing is there inside the glass tube. To say no particles are inside the glass tube, we use the term vacuum. Vacuum. So there is a vacuum in it. It means no particles are inside the glass tube. Okay, so this is the complete arrangement. Star point and write. The following arrangement can be used. The following arrangement can be used to generate X-rays. The following arrangement can be used to generate X-rays. The following arrangement can be used to generate X-rays. The following arrangement can be used to generate X-rays. Okay, draw it there. Please draw the figure. Draw it. And if you have any further doubts, you can ask while you are drawing. Can someone take a photo of the things that we have written today and send to the WhatsApp group there? Somebody please take a photo of the things that we have written today and send to the WhatsApp group. It will be helpful all the students join to the class now. Is audio okay, dear? Please tell me whether
Yes, sir.
it's okay, right?
Yes, sir.
What about the video quality? Is it clear?
It is clear, sir.
Okay, thank you, dear.
It is now okay, so it used to be a little upset, but now it's fine.
Sometimes video and audio may not be clear because when my network, the device that I use for the network may be heated. So I have several network devices. So once video and audio are not okay, just send me a message so I can change one device from to other device. So then you will get the continuously good video and audio quality. Okay. So once you inform me, I'll change the device.
Sure. Okay, sir.
Yes,
Someone please take a photo of the things that we have written today and send to the WhatsApp group, dear. It will be a help for, or at least send to me. It will be a help for other students. There may be some students join to the class late, so we must help them. We must help the other students. Who wants more time to draw the figure here? Shall we continue the lesson? Anybody wants any more time to draw the figure?
Okay, sir.
Okay, write in the point form. Write in the point
Excuse me.
form. E1 voltage supply is used to
Sir, can you repeat it?
E1 voltage supply is used to generate heat energy E1 voltage supply is used to generate heat energy in the heating coil. E1 voltage supply is used to generate heat energy in the heating coil. Within brackets, simple A. Heating coil is marked as simple A. I will not erase this figure. Don't worry, I will not erase. Don't worry, I will not erase. Promise. So E1, capital E1 voltage supply is used to generate heat energy in the heating coil. Within brackets, simple A. Full stop. Due to the same point, due to the generated heat energy, due to the generated heat energy, due to the generated heat energy, electrons are emitted from the metal simple A. Due to the generated heat energy, electrons are emitted from the metal simple A. From the metal simple A. Due to the generated heat energy, electrons are emitted from the metal simple A. Full stop. This effect is known as Bem-Strahlung effect. Check the Zoom chat for the spellings. This effect is known as Bem-Strahlung effect.
Sir, I'm not in the group.
Due to the generated heat energy, electrons are emitted from the metal. This effect is known as Bem-Strahlung effect. Bem-Strahlung effect. Full stop. Okay, dear.
Yes, sir.
Right. Please continue. These generated electrons are free to move to any direction. These generated electrons are free to move any direction. Therefore, they are said to be free electrons. Therefore, they are said to be free electrons. Therefore, they are said to be free electrons. These generated electrons are free to move any direction. Therefore, they are said to be free electrons. Full stop. So I have said everything about this heating coil and this one. The Bem-Strahlung effect is not in our syllabus. You just want to know only the name, not more than that. Right. Somebody read the note that we have written for E1 voltage, heating coil, and the metal. The metal which generates free electrons. Read that note for all of us. Help others.
Supply is used to generate heat energy in the heating coil. Due to the generated energy, electrons are emitted from the metal A. Is free any, therefore they are said to be free electrons.
Very good. One more student, please read the note, dear. One more student. Help others.
E1 voltage supply is used to generate heat energy in the heating coil A. Due to the generated heating energy, electrons are emitted from the metal A. This effect is known as Bremsstrahlung effect. These generated electrons are free to move in any direction. Therefore, they are said to be free electrons.
Very good. Excellent. Next point. Next point. If E1 voltage is a larger, if E1 voltage is larger, if E1 voltage is larger, if E1 voltage is larger, comma, more heat energy will be generated. If E1 voltage is larger, comma, more heat energy will be generated. If E1 voltage is larger, more heat energy is generated. Full stop. When more heat energy is generated, more electrons are removed from the metal. When more heat energy is generated, when more heat energy is generated, more electrons are removed from the metal. More electrons are removed from the metal. Full stop. Then more electrons will travel from A to B, simple A to simple B. Then more electrons will travel from simple A to simple B. Then more electrons will travel from simple A to simple B. And simple A, then more electrons will travel from simple A to simple B. And more electrons will collide with the target metal. Then more electrons will travel from simple A to simple B, and more electrons will collide with the target metal. More electrons will collide with the target metal. Full stop. Full stop. When more electrons collide with the target metal, when more electrons collide with the target metal, when more electrons collide with the target metal, comma, more X-rays are generated. More X-rays are generated. When more electrons collide with the target metal, more X-rays are generated. More X-rays are generated. Full stop. Full stop. When larger number of X-rays are generated, when larger number of X-rays are generated, when larger number of X-rays are generated, comma, it is said that when larger number of X-rays are generated, comma, it is said that, use this word, use a different color to write this word. When larger number of X-rays are generated, it is said that, look at board, use a different color pen and write intensity of X-rays. Intensity of X-rays. It's better to use a different color pen or highlight. It is said that intensity of the X-rays, normal color, is increased, comma, is increased. When a larger number of X-rays are generated, it is said that the intensity of X-rays, comma, is increased. Got it? Right, now somebody unmute the mic and read that note. Help all of us.
If E1 voltage is larger, more heat energy will be generated. When more heat energy is generated, more electrons are removed from the metal. Then more electrons will travel from A to B, and more electrons will collide with the target metal. When more electrons collide with the target metal, more X-rays are generated. When larger number of X-rays are generated, it's said that intensity of X-rays is increased.
It is said that intensity of X-rays increased. Very good. Would listen to that note again. Who wants to listen to note again? Because if you have missed it, please tell me. Right, now somebody please tell me, if I want to increase the intensity. Intensity means if I want to generate more X-rays, if I want to have a larger intensity, what should I do? Somebody unmute the mic and tell me.
Increasing the power?
Sorry?
Increasing the power?
If you that's the point. If you say power must be increased, no marks are given. Why? If you say power is increased, or if you say voltage should be increased, or more current should be given, no marks given. Why? There are two power sources, V1, E1, E2. So if you say power is increased, you may be increasing the power of E2, or maybe increasing the power of E1, or maybe increasing E1 voltage or E2 voltage. You must specify. That's why I asked. But I'm happy with your answer. So what should I do if I want to increase the intensity of X-rays? Somebody please tell me.
Should increase the frequency.
Frequency? I didn't use even the term frequency. I didn't use that term. Read the note again. Sorry?
So want to increase the rings of the coil.
To increase the rings of the coil. Ammu. Oi. Read the note
Yes,
again.
sir.
Increase the E1 voltage.
We must increase the E1 voltage. We must increase the E1 voltage. When E1 is increased, more current flows through the coil. When more current flows through the coil, more heat energy is generated. When more heat energy is generated, more electrons are emitted from the metal symbol A. When more electrons are generated, they will collide with the target metal. When more electrons collide with the target metal, more X-rays are generated. More X-rays are generated means intensity is increased. Intensity directly related to the number of X-rays generated per unit time per second. So what should I do if it is asked me to increase the intensity of X-rays? What should I do? Somebody?
Should increase the E1, sir.
We must increase the E1 voltage. Is it clear for you? Who would like if I explain it again? Anybody in the class? Let's do something like this. I'll ask a student to read the note again. Listen to the note carefully, then you will understand. Okay, dear? I'll ask a student to read the note again. Once you listen to the note carefully, you will understand. Jumana, can you read the note? Please read everything slowly and loudly.
Yes, sir. The last point only or from the beginning, sir?
Everything, dear. Everything read slowly but loudly, right?
E1 voltage supply is used to generate heat energy in the heating coil A. Due to the generated heat energy, electrons are emitted from the metal A. This effect is known as Bremsstrahlung effect. These generated electrons are free to move any directions. Therefore, they are said to be free electrons. If E1 voltage is larger, more heat energy will be generated. When more heat energy is generated, more electrons are removed from the metal. Then more electrons will travel from A to B, and more electrons will collide with the target metal. When more electrons collide with the target metal, more X-rays are generated. When larger number of X-rays are generated, it is said that intensity of X-rays is increased.
Very good. Now, is it clear? Still, who wants me to explain the story again? Check. Is there anybody still that I want to explain it? Then I'll use a different method. Right, listen dear. There is another place to prove that when E1 increases, intensity increase. There is another place where when we discuss cohesion, there are numerical calculations. Once we do numerical calculations by keeping E1 as 2 volt, and once E1 voltage is increased from 2 volt to 6 volt, we can easily prove that intensity is increased by doing some numerical examples. But now we are not going to do it. Got it? Right. Then we are going to use some part of the theory that we have learned in mechanics. We know that when objects collide, heat energy is generated. So due to the collisions of these electrons, huge amount of heat energy is generated in the target metal. We must have a cooling system separately to reduce the temperature of the target metal. So the cooling system can be arranged in many ways, right? So one of the method is we can use a heat sink, but that will not be enough for this. The best thing is we can keep a metal tube which is in contact with the target metal, like this. A metal tube is kept in contact with the target metal. They are bonded together. A very good heat conductor, and we may allow a liquid to flow through it. A liquid should flow through it. So we must have a different mechanism, a separate mechanism to do it. So this is a flow of a liquid. A flow of a liquid. So mostly with this water will not be enough. So we have to use a good liquid which absorbs heat energy, right? So we must apply something to reduce the temperature. So in the examination, sometimes they will ask you to draw this one. I don't know whether you have enough space to draw a tube. This is liquid in. This is liquid in. This is liquid out. So when the liquid flows out, it absorbs heat energy from the target metal. So this mechanism is used to reduce the temperature. Or there must be a method to reduce the temperature. Otherwise, this solid metal will be converted into a liquid. So after that, you will not get X-rays. You will get a flow of ions. A liquid ion can be obtained. Lava can be obtained. So there must be a cooling system. Unfortunately, I forgot to draw it at the beginning. So if you have enough space, please draw it, or let's write a sentence. Start there. Ahas, you have asked a very good question. That's why I'm going to answer that question within next 5 minutes. I'm very happy with your question actually. And the other thing is, let's say audio is not clear. When I'm talking to you, audio is not clear. There are two possible reasons. If audio is not clear, there are two possible reasons. The first reason is the teacher's network connection may be not good, or the student's network will not be good. You can identify whose network is not good. When I am talking to you, audio is not clear. But when another student is reading the note, audio is very clear. So it means problem with my network. Got it? The second thing is, when I'm talking to you, you can't hear my voice properly. When a student is reading the note, again, audio is not clear. So it means the problem is with your network, most probably. Got it? So then you can identify whether your network connection is good or bad. And the other thing is, if you use a mobile phone or a tablet to join to the classes, if you use a cover for your device, the temperature of your device will be very high. Once the temperature of electronic devices are very high, audio and video quality are reduced. So you have to keep your device at a low temperature. You have to use a fan, or you have to remove the cover of the device. Okay, and it is even true for if you use a Wi-Fi router. The temperature of router should be at a lower, it should be at a lower one temperature. Right. I think you have drawn it. Right. Star point and right. Star point and right. Next star point. When the electrons collide with the target metal, a huge amount of heat energy is generated in it. When the target metal collide with the when the electrons collide with the target metal, comma, huge amount of heat energy. When the electrons collide with the target metal, huge amount of heat energy is generated in the metal. When electrons collide with the target metal, huge amount of heat energy is generated in it. When the electrons collide with the target metal, a huge amount of heat energy is generated in it. A huge amount of heat energy is generated in it. Therefore, there is a possibility for the metal. Therefore, there is a possibility for the metal to be melted. When the electrons collide with the target metal, huge amount of heat energy is generated in it. Therefore, there is a possibility for the metal to be melted. So therefore, there is a possibility for the metal to be melted. Okay. So if we use a metal something like lead, what will happen? Let's say you use the metal lead here, then what will happen to the lead? They will ask this kind of questions in the exam. The target metal is made by lead. So then what will happen?
The lead will melt off.
Lead will be melted and you will get liquid lead. Then there will not be a target metal. Then X-ray will not be generated. Why? Lead has a very low, compared to the other metals, lead has a lower melting point. So therefore, we must use a metal with a larger melting point. Then the target metal will not be melted. Got it? So to protect the target metal from these high generated heat energy, we must select a metal with a higher melting point. Okay, so please try. The target, therefore, full stop, and then therefore, the target metal should have a higher melting point. Therefore, the target metal should have a higher melting point. Therefore, the target metal should have a higher melting point. Full stop. Normally, tungsten is used to make the target metal. So because tungsten has a larger, higher melting point. Normally, tungsten is used to make the target metal. Normally, tungsten is used to make the target metal. Next point. Next star point. A separate cooling system should be arranged. A separate cooling system should be arranged. A separate cooling system should be arranged to reduce the temperature of the target metal. A separate cooling system should be arranged to reduce the temperature of the target metal. A separate cooling system should be arranged to reduce the temperature of the target metal. Full stop. Full stop. To achieve it, comma, a flow of liquid is supplied to the. To achieve it, a flow of liquid is supplied to the target metal. To achieve it, a flow of liquid is supplied to the target metal. A flow of liquid is supplied to the target metal. To achieve it, a flow of liquid is supplied to the target metal. Okay, dear. So sometimes they will ask about this flow of liquid. So please remember that this flow of liquid is used to reduce the temperature of the target metal. It is said to be a cooling mechanism. Okay, dear. Lamai, did you write everything?
Yes, sir.
Right. Can somebody unmute the mic and read that note? The note that I have given about the melting point and the cooling system. Please read those things.
A separate cooling system should be arranged to reduce the temperature of target metal. To achieve it, a flow of liquid is supplied to the target metal. When the electrons collide with target metal, a huge amount of heat energy is generated in it. Therefore, there is a possibility for the metal to be melted. Therefore, the target metal should have higher melting point. Normally, tungsten is used to make a target metal. A separate cooling system should be arranged to reduce the temperature of target metal. To achieve it, a flow of liquid to the target metal.
Very good. Now students have fully understood me. When the students are silent, teacher will also be silent. When I ask you to read, you should read. So I'm very happy with, because you must help each other here. There are very a little amount of students are with me. So many students are there in Sri Lanka, but I have very little amount of students. But I always try to increase the quality of my students. So please help each other. I'm really happy. Right, now let's talk about this E2 voltage and the strength of the X-rays. Right, so please write E2 voltage supply. Next point, E2 voltage supply is used to move electrons from simple A to simple B with an acceleration. E2 voltage supply is used to move electrons from simple A to simple B with an acceleration. With an acceleration. E2 voltage supply is used to move electrons from simple A to simple B with an acceleration. With an acceleration. Okay? If E2 voltage is increased, if E2 voltage is increased, if E2 voltage is increased, the electrons will travel with a larger acceleration. If E2 voltage is increased, the electrons will travel with a larger acceleration. With a larger acceleration. Full stop. Then electrons will achieve a very large velocity. Then the electrons will achieve a very large velocity. Then the electrons will achieve a very large velocity. When the velocity is higher, when the velocity is higher, the electrons will have a larger amount of kinetic energy. When the velocities are higher, the electrons will have a larger amount of kinetic energy. The electrons will have a larger amount of kinetic energy. Full stop. When the electrons with larger kinetic energy, when the electrons with a larger kinetic energy, comma, when the electrons with a larger kinetic energy, comma, collide with the target metal, when the electrons with a larger kinetic energy collide with the target metal, comma, X-rays are generated with a larger amount of energy. X-rays are generated with a larger amount of energy. X-rays are generated with a larger amount of energy. Full stop. When X-rays have more energy, comma, they are, look at board and use a different color pen. Their penetration power is larger. When X-rays have more energy, comma, their penetration power is higher. Somebody please tell me what the penetration power is, dear. Do you know what the penetration power is, someone?
The ability to go through an object.
It is the ability to go through some objects. For example, X-rays are able to go through our muscles. So they are able to go through the muscles, but they are not able to go through the bones. So they go through the muscles. Once the X-rays incident on the bones, they are reflected. So then we are able to get photos of the bones inside human body. So penetration power means the ability of X-rays to go through the objects. So when X-rays have more energy, they have larger penetration power. To have larger penetration power, the electron should have more kinetic energy. To have more kinetic energy, electrons must have a larger velocity. For the electrons to have a larger velocity, they must have a larger acceleration. To obtain a larger acceleration, the E2 voltage supply to A and B should be larger. So if you use the larger E2 voltage supply, you get X-rays with higher energy, X-rays with larger penetration power. Okay, Ahas, I think that's the answer for your question. Is the story clear here? Would like if I explain the story again? Anybody in the class? Right, can somebody read the note that I have given for E2 voltage supply? Somebody please read everything for E2 voltage supply.
E2 voltage supply is used to move electrons from A to B with an acceleration. If E2 voltage is increased, the electrons will travel with a higher acceleration. Then electrons will achieve a very large velocity. When the velocity is higher, the electrons will have a larger amount of kinetic energy. When the electrons with larger kinetic energy collide with the target metal, X-rays are generated with a larger amount of energy. When X-rays have more energy, their penetration power is higher.
Okay, very good. So, very good. Thank you, dear. So, we want electrons to move with larger velocity, right? But X-rays, velocity of X-rays cannot be increased or decreased. What is the velocity of X-rays, dear?
Light.
Yeah, velocity of X-rays is equal to the velocity of light. So therefore, we cannot increase or decrease the velocity of X-rays. The only thing we can change the velocity of moving electrons in between simple A and simple B. To change the velocity of moving electrons in between A and B, we must use a higher voltage supply such as E2. Right. Please try it. We are going to do a small calculation. We are going to do a small calculation. So please try it. Please try it. First statement, the potential difference between simple A and simple B. The first statement, the potential difference between simple A and simple B. The potential difference between simple A and simple B equals E2 volt. E2 volt. The potential difference between simple A and simple B equals E2 volt. Next statement. For the next statement, actually, you will need two lines. So you have to use the curly bracket and write it like this. Next statement. Therefore, listen. First statement. Listen again. First statement. The potential difference between simple A and simple B equals E2 volt. Next statement. Therefore, amount of energy given. Therefore, the amount of energy given to a charge of 1 coulomb. Therefore, the amount of energy given to a charge of 1 coulomb, which is moved from simple A to simple B. Therefore, the amount of energy given to a charge of 1 coulomb moved from simple A to simple B equals E2 within brackets joule. E2 joule. Let me read the two statements again. Listen carefully. The potential difference between simple A and simple B equals E2 volt. Therefore, amount of energy given to a charge of 1 coulomb moved from simple A to simple B equals E2 joules. E2 joules. What is the relationship between the first statement and the second statement? Somebody please tell me. What is the relationship between the first and second statements? Someone? Lamai, what is the relationship between first and second statements?
So they are
Do not suddenly mute your mic, then I will hear only half of the sentence that you tell me. Unmute the mic and tell me again, what is the relationship between first and second statements?
So they are equal.
They are equal. The second is the definition of potential difference. The potential difference is defined, is said to be the amount of energy needed to move a unit positive charge from a point at lower potential to the point at higher potential. What is the definition of electric potential difference? It is the amount of energy needed to move a unit positive charge from the point at lower potential to the point at a higher potential. Here, the reverse process is take place here. What is the reverse process here? Charges are moved from a point at higher potential to the point at lower potential. Energy is generated. Clear? So if the potential difference provided by the battery is E2 volt, it means when 1 coulomb of charges, here electrons, 1 coulomb of charges, here electrons, move from A to B, E2 joules of energy is given to those electrons. Those E2 joules converted into the kinetic energy of the electrons. Clear? So where did we learn these potential difference and energy cases, dear? In which lesson? Lamai. Where did we learn the potential difference and energy generated by an battery electric circuit? What's the lesson? You must tell me at least name of the lesson, right? Otherwise, I will not teach you. Someone?
Electricity lesson?
Yes, we learn, very good. We learn these things in current electricity lesson. In current electricity lesson, do you remember that I have drawn a battery like this? Do you remember? A battery is there like this. Its voltage is given as 9 volt. Then I ask what is the meaning of this 9 volt? Do you remember this? Do you remember this circuit here? Terminal voltage of the battery is given as 9 volt. I have asked what is the meaning of this 9 volt. So this theory is applied here. Read the electricity note again. Exam is coming closer. Right. So what is somebody unmute the mic and read the first 2 statements again. Somebody please read the first 2 statements again.
Potential difference between A and B equals E2. In the curly brackets, therefore, amount of energy given for a charge of 1 coulomb which moved from A to B, close curly bracket, is equals E2.
Very good. Is there anybody who missed the note there? Because this lesson is very important. If you have missed even a single sentence, please tell me. Right. Please write next equation. Therefore, sorry, not therefore. The amount of charge on an electron. 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 Let me use it as simple Q coulomb. We know the amount of charge on an electron, but I would like to use a symbol. The amount of charge on an electron equals simple Q coulomb. Simple Q coulomb. Full stop. Not full stop. That's the end. Next statement. Therefore, the amount of energy given by the E2 voltage supply. Again, you will need 2 lines. Again, you will need 2 lines. Therefore, the amount of energy given by the E2 voltage supply, given by the E2 voltage supply to an electron. Therefore, the amount of energy given by E2 voltage supply to an electron, when it is moved from simple A to simple B, therefore, the amount of energy given by the E2 voltage supply to an electron when it is moved from simple A to simple B. Therefore, the amount of energy given by the E2 voltage supply to an electron when it is moved from simple A to simple B. For 1 coulomb, E2 joules given. Therefore, for Q coulombs, how much energy will be given here? Someone? Lamai?
E times Q.
Yes, dear. When 1 coulomb of charge moves from A to B, to that 1 coulomb of charge, the battery gives E2 joules. Now, Q coulomb of charge moves from A to B. Then it will give Q times E2 or E2 times Q. E2 is the energy given to 1 coulomb. Therefore, Q times E2 is the energy given for Q coulomb. So, unit is joule. Unit is joule. Right, India. Okay. Star point and write the above energy is converted into the kinetic energy of the electron. The above energy is converted into the kinetic energy. The above energy is converted into the kinetic energy. The above energy is converted into the kinetic energy. Leave a line and write. Therefore, equation. Therefore, leave a line and write. Therefore, the amount of kinetic energy on an electron. Therefore, the amount of kinetic energy in an electron when it collides with the target metal. Therefore, the amount of kinetic energy in an electron when it collides with the target metal. When it collides with the target metal. Therefore, the amount of kinetic energy in an electron when it collides with the target metal equals Q times E2. Q times E2. Let me mark this as my first equation. Let me mark it as my first equation. Q times E2. I have marked it as my first equation. Can you see the board here? Here, when I write here, can you see the board?
Yes, sir.
Yeah. So this is the kinetic energy of an electron when it collides the target metal. So if the mass, if the mass of an electron is simple limb, if the velocity of electron is v, then what is the kinetic energy of the electron here? Somebody?
Pardon, sir?
If the mass of an electron is simple limb, if the velocity of an electron is v, what is its kinetic energy?
Half
Half
mv
mv
squared.
square.
Half mv square. Mage amme, you took a long time to say it. So please write. Please write next equation. But the kinetic energy of an electron when it hits the target metal. Next equation. But the kinetic energy of an electron when it hits the target metal. When it hits the target metal equals half mv square. Let us take it as the second equation. But the kinetic energy of an electron when it hits the target metal equals half mv square. Take it as the second equation. Okay, dear? Lamai?
Okay, sir.
Right. So what do you think about these
Okay,
1
sir.
and 2 equations? What do you think about 1 and 2 equations?
Equal.
They are equal. Very
Equal.
good. So one, please do not mute the mic at once. Then we can't hear you properly. Tell me the answer and wait 10 seconds after that mute it. Right. So 1 and 2 equations equal because they both of them give the same kinetic energy. So let me write that the second equation equals the first equation. The second equation tells us half mv square equals q times E2. So if I take 2 and m to the other side, I'll get v square equals 2 goes up, m goes down, 2 over m times q E2. From this, you can find the velocity v. From the third equation, you can find the velocity of an electron when it collides the target metal. Complete it here. From this equation, you can find the velocity of an electron when it hits the target metal.
Can somebody please repeat the statement for equation 2?
Second statement said as, but the kinetic energy of an electron when it hits the target metal. The second equation, the amount, but the kinetic energy of an electron when it hits the target metal equal half mv square. Okay, dear?
Thank you, sir.
Right. Next star point. Next star point. Let us apply the following equation. Next star point. Let us apply the following equation to an electron. Let us apply the following equation to an electron which is moving from simple A to simple B. Let us apply the following equation to an electron which is moving from simple A to simple B. Let us apply the following equation to an electron which is moving from simple A to simple B. Look at board. To this direction, A to B, simple A to simple B, don't write. I apply the equation V square equals U square plus 2AS. The velocity of an electron when it hits the target metal is V. The velocity of an electron when it starts its motion is 0. The initial velocity of an electron is 0. Plus 2, acceleration. We don't know. We don't know what the acceleration is. Distance between simple A and simple B. Let me take it as simple D. So V square equals 2AD. 2AD. But what is V square according to the third D equation here? Let me mark this as 4. Somebody unmute the mic and tell me what is V square according to the third D equation?
2 over m into q into E2.
This one, 2QE2 over simple A. So please
2
write
over
them here.
m in
Very good.
2
Please
over
write.
simple m into q into
Very good. Right. So please write this. And what is D here? D is the distance. Simple D is the distance between A and B. Now my students are very good. Very good. Write them all. I'm so happy. I'm really happy. Right. So now I'm going to combine I'm going to combine 4 and 3 equations, or 3 and 4 equations. I'll write 3 equations somewhere else. V square equals 2QE2 over simply. I'll write somewhere, you can't see it. Right. I'm going to combine 3 and 4 equations from 3 and 4 equations. Right? The fourth equation tells us V square equals 2AD. Simple D is the distance between A and B metals. And third equation tells us V square equals 2 into Q into E2 divided by simple limit. Right? Equals 2AD. If I take this 2 and D to this side, if I take this 2 and simple D to this side by cross multiplication, I can subject the acceleration. 2 into Q into E2 over M. This 2 comes here. This D comes here, equals A. So what will be the final expression for acceleration here? What are things that can be cancelled out? This 2 and 2 cancelled out. Q and E2 will be there. Then we will get acceleration equals Q E2 divided by dm. Q E2 divided by dm. So let me take this as my fifth equation. Complete. So now we have an expression for the acceleration. We have an expression for the acceleration of the electron. So we have written some mathematical parts. So the theory is less and many mathematical simplifications are there. And if you have missed any note of this matter and relation lesson, don't worry, because you know that Ahas will send us the complete note. He will convert this note into PDF and he will send it. So don't worry if you were late to join to the class. There is a kind-hearted student with us, and others will also send if you ask, definitely. Right now, I'm going to do something like this. I want to erase these things here. So if you want, please take a screenshot. So actually, you will be, if you remember the theory, you will be very happy once I show you this. If you remember the theory of electric field lesson. Right, listen dear. To an electron, so I'm going to apply this equation to an electron which is moving from A to B. To an electron, to this direction, I apply the equation F equals ma. Right? The force acting on an electron equals mass into acceleration. What is acceleration here? Q E2 over dm. Acceleration is Q E2 over dm. Now m and m cancel out. Then we get force acting on an electron equals Q E2 over d. You are going to obtain something very interesting from this. Actually, whether you write this or not here, it's not a problem, but I want to show you a very small thing. Write it there. So we have found the force acting on an electron. So what is the amount of charge on an electron here? Somebody please tell me. Somebody please tell me the amount of charge on an electron according to the things that we have written. Someone?
Q.
Q coulomb.
Q coulomb. Very good. So force acting on an electron is F. It means the force acting on Q coulomb of charge is F. So then we can find the force acting on 1 coulomb of charge. There's a certain definition for it. What is the force acting on 1 coulomb of charge? Somebody please tell me. That's the special definition. Can somebody tell me? What is the term
So can you
that
repeat
we
the
used
question
in
again?
electric field lesson? Listen carefully. What is the term that we used in electric field lesson for the force acting on a unit positive charge? Somebody please tell me.
Electric field
I didn't hear you
intensity.
properly, dear. Try again.
Electric field intensity.
Very good. Yes, Ahas. Electric field intensity. The force acting on a unit charge or 1 coulomb of charge in an electric field is said to be the strength of the electric field or electric field intensity. So it means from this, we can find electric field intensity. Right. So leave a line and write next equation. Actually, we are reached to the end. That's the end of the lesson. That's the end of this section. After that, we should discuss a past paper question. So please write statement. The force acting on an electron, the force acting on an electron, which is moving from simple A to simple B. The force acting on an electron, which is moving from simple A to simple B, which is moving from simple A to simple B, equals Q E2 divided by dm. Q E2 divided by dm. The force acting on an electron, comma, which is moving from simple A to simple B, equals Q E2 divided by dm. Q E2 divided by dm. Okay. Next equation. Next equation. The amount of charge on an electron. Next equation. The amount of charge on an electron equals the amount of charge on an electron equals simple Q coulomb. Look at board and write. Simple Q coulomb. The amount of charge on an electron equals simple Q coulomb. Next equation. Therefore, the amount of the force acting on, next statement, therefore, the amount of force, acting on, look at board, the amount of force acting on, look at board, Q coulomb of charge, Q coulomb of charge. Therefore, the amount of force acting on a Q coulomb of charge equals Q E2 divided by dm. QE2 divided by dm. Okay, dear. Wait, sorry, there is a mistake. Simple M is not there. There's a mistake. Say, somebody please read the first statement.
Yes, sir.
Please read this statement. There's a small mistake. Here, read.
The force acting on an electron
The force acting
which
on an
is moving
electron
from
is
A.
F. Yeah, the force acting on an electron is F. That is QET over D. M is not there. QE2 over D. Please correct the mistake here. There is no simple link. The force acting on an electron is QET over E2 over D. Therefore, the amount of charge in the electron Q. Therefore, the amount of force acting on Q coulomb of charge is QET E2 over D. No M is there. Sorry, M is not there. Sorry, mistake. M is not there. In the force, M is no M term in the force. Okay. Now somebody please unmute the mic and read these three statements that I have written in blue color. Somebody unmute the mic and read them.
The force acting on an electron which is moving from A to B equals QE2 over D. The amount of charge on an electron equals Q coulomb. Therefore, the amount of force on Q coulomb of charge is equals QE2 over dm.
The amount of force acting on Q coulomb of charge equals QE2 over simple D. There is no M term. QE2 over simple D. There is no simple M term. Okay, dear?
Okay, sir.
Right. Next statement. Therefore, the amount of force acting on Therefore, the amount of force acting on 1 coulomb of charge. 1 coulomb of charge. Therefore, the amount of force acting on 1 coulomb of charge, which is moving from simple A to simple B. Therefore, the amount of force acting on 1 coulomb of charge, which is moving from simple A to simple B. Somebody please tell me the method that should be used to find it. What should I do? What should I do to find the amount of force acting on 1 coulomb of charge, dear? I know the force acting on Q coulomb of charge. So if I want to
instead
find
of
the
Q, so instead of Q,
divided by Q. Very good. Force acting on Q coulomb of charge is QE2 divided by B. So this is the force acting on Q coulomb of charge. Therefore, the force acting on 1 coulomb of charge means divided by Q. Am I right? Okay or not? Lamai, is this okay or not?
No, sir, I didn't get it. No, sir, I didn't understand it.
Right. What is this statement here? Please read this statement again. Read it loudly.
Therefore, the amount of force acting on Q coulomb of charge equals QE2 over D.
So force acting on Q coulomb of charge is QET over D. QET over D. Then what is the force acting on 1 coulomb of charge here?
D.
It's something like this. Price of 10 buns. Price of 10 buns, 100 rupees. Then what is the price of a bun? How do you find it there?
Yeah, okay.
should be divided by
So
the
you
number
divide
of
100 by
bonds.
10.
Am I right?
When?
If the price of 20 bonds 100 rupees, then the price of a bond is 100 divided by 25 rupees. Got it, dear? Similarly,
Got it, sir. Thank you.
Similarly, if the amount of force acting on Q coulomb charge is this, then the force acting on 1 coulomb of charge should be this. Force on Q coulomb of charge divided by Q is the force acting on 1. Right. So, okay. So when you are confused, you must ask, then only you can overcome the difficulties. So then QE2 divided by D. This division becomes multiplication when you get the reciprocal. So Q will be 1 over Q, then division becomes multiplication. Now this Q and Q cancelled out, then you get E2 over simple D. Unit is, E2 is volt, D is meter, therefore the unit will be volt per meter. Write it here. Write it. Yes, dear. Now, yes, once, now somebody please tell me what is the definition of this, dear? Charge, the force acting on 1 coulomb of charge. What is it, dear? The force acting on 1 coulomb of
Excuse me,
charge
sir,
is
can you ask
defined as?
again?
Yes, Sadhushika?
So can you ask the question again?
Yeah.
Please?
The force acting on 1 coulomb of charge has a certain definition. What is the term that we use to indicate the force acting on 1 coulomb of charge?
Electric field intensity.
Very good, Seshani. That is electric field intensity. Star point and write. The force acting on 1 coulomb of charge, the force acting on 1 coulomb of charge is said to be the electric field intensity. The force acting on 1 coulomb of charge is said to be the electric field intensity. The force acting on 1 coulomb of charge is said to be the electric field intensity. Right. So leave a line and write the final equation. This is the final thing that we are going to write. So please write, therefore is equation. Therefore, the electric field intensity between simple A and simple B. Therefore, the electric field intensity between simple A and simple B equals E2 divided by simple D. Therefore, the electric field intensity between simple A and simple B equals E2 divided by D. E2 divided by D. What is this actually? We have learned this equation in electric field lesson. We have learned this equation in electric field lesson. So please draw a box around it. Electric field intensity between simple A and simple B equals E2 divided by D. What is D? What is E2 dear? What is E2? E2 is the potential difference between A and B. E2 is the potential difference between A and B. So let me name them. Potential difference. Potential difference between A and B. E2 is the potential difference between A and B metal plates. What is simple D here? What is simple D? D is the distance. Is the distance between A and B. Right, India? So this equation, do you remember that we have learned this equation in our electric field lesson? To remember it? Anybody in the class? So we have proved the same equation in electric field lesson. Electric field intensity equals potential difference between potential difference divided by the distance. Potential difference divided by distance is the electric field intensity. So even we have proved it here in matter and radiation lesson. So that's one of the beauty in science. Right. Next star point, I think you have written, but I promise I will not erase. Star point and write. When electrons moving from simple A to B, when electrons moving from simple A to simple B, comma, if there are particles in the glass tube, when electrons moving from simple A to simple B, if there are particles in the glass tube, if there are particles in the glass tube, electrons will collide with them. Electrons will collide with them. When electrons moving from A to B, comma, if there are particles in the tube, comma, the electrons will collide with them. The electrons will collide with them. Then the kinetic energy of the electrons will be wasted. then the kinetic energy of the electrons will be wasted. Then the kinetic energy of the electrons will be wasted. Full stop. When the kinetic energy is wasted, when the kinetic energy is wasted, comma, the penetration power of X-rays, when the kinetic energy is wasted, comma, the penetration power of the X-rays, comma, is reduced. When the kinetic energy is wasted, comma, the penetration power of X-rays, comma, is reduced. Therefore, there should not be particles in the glass tube. Therefore, there should not be particles in the glass tube. There should not be particles in the glass tube. Then a vacuum is created in the glass tube. Then a vacuum is created in the glass tube. Then a vacuum is created in the glass tube. So sometimes it will be asked in the exam why there is a vacuum in the glass tube. So this is the reason. So I have given you the reason. Right. Can somebody unmute the mic and read that star point again?
When electrons move from A to B, if there are particles in the glass tube, electrons will collide with them. Then the kinetic energy of the electrons will be wasted. When the kinetic energy is wasted, the penetration power of the X-rays is reduced. Therefore, there should not be particles in the glass tube. Then a vacuum is created in the glass tube.
Very good. Thank you. Who would like to listen to the note again? Who missed the note? Right. One more star point. This equation is related to both electric field as well as matter and radiation. In both lessons, we learned the same equation. So it's not related only to one, but related to the both lessons. Right. Star point and write. Some amount of kinetic energy. Some amount of kinetic energy of a moving electron. Some amount of kinetic energy of a moving electron is given to the generated X-ray, is given to a generated X-ray. Some amount of kinetic energy of a moving electron is given to a generated X-ray. Generated X-ray. Full stop. But only a very small amount of the kinetic energy, full stop and continue, but a very small amount of the kinetic energy, but a very small amount of the kinetic energy is given to an X-ray. But a very small amount of kinetic energy is given to an X-ray. Full stop. Most of the kinetic energy is converted into heat energy. Most of the kinetic energy is converted into heat energy. Clear? So when an electron collides with a target metal, little amount, a very little amount
Could you
of the
repeat that,
kinetic
please?
energy of the electron is given to the X-ray. The rest is converted into heat energy. Next star point. Next star point. When an
Excuse me, sir. Can you
electron
please
collide
repeat the
with,
sentence again?
can somebody read that point here? Can somebody read that star point?
Some amount of kinetic energy of a moving electron is given to a generated X-ray, but only a very small amount of kinetic energy is given to an X-ray. Most of the kinetic energy is converted to heat energy.
Okay, very good. So please try it. Please continue. Next star point. When an electron collides with the target metal, only a single photon, look at board. Only a single photon, look at board and write. Only a single photon of an X-ray. When an electron collides with the target metal, only a single photon of an X-ray is given out by the metal. Full stop. Some amount of the kinetic energy of electron, is given to the photon. Some amount of kinetic energy of the photon is given to the electron. Some amount of kinetic energy of the electron is given to the photon. Right. In which lesson that you hear about photons for the first time when you learn physics? Do you remember your past?
Light lesson, lasers.
No, before light lesson, before lasers, you have learned it. Even I am going to explain lasers again. Where did you first hear the term photon when you start your advanced level? In which lesson?
So units and dimensions.
Unit and dimensions lesson. Units and dimensions lesson you have learned, heard it. What's the thing that you have heard about photons in units and dimensions lesson? If you were in my class, you must remember it because I explained a lot about this. Lamai. What did I tell you about the photon in units and dimensions lesson? Somebody? මතක නෑනේ. ඔන්න ඔය ක්ලාස් ෆීස් ගෙවන ගමන් ළමයි චූටි වහ කුප්පියකුත් එවන්නකෝ. මට සැනසෙල්ල බීලා දාන්න. I have taught about photons, you don't remember. So please send me a small amount of poison with the class fees. Because whatever I teach, you don't remember. Eh?
So Planck's constant.
Sorry, try again. Yes, dear, please tell me.
Planck's constant. So Planck's constant.
When we learned about Planck's constant, we have said about photon. Very good. Now you slightly remember your past. I'm so happy. When we were learning about Planck's constant, we learned about photon. What did I tell you about the photon and the Planck's constant, dear? Someone? Planck's constant, first lesson. Photon, matter and radiation, the last lesson. When you learn the last lesson of the syllabus, you don't remember the first lesson, right? Very good. So we have said electromagnetic waves transfer energy as energy packets. A packet of an energy is said to be a photon and or a quanta. Amount of energy stored in a photon is given by the equation E equals hf. H is Planck's constant, F is the frequency of the electromagnetic waves. Do you remember that point that we learned in math and radius in units and dimensions lesson? At least do you remember that I have said something like this in that lesson? Lamai. Right. The electron has some amount of kinetic energy. Part of that kinetic energy is given to the X-ray. When one electron collides with the target metal, one photon is given out. The amount of energy in that photon is hf. The amount of kinetic energy in an electron, somebody tell me, we have obtained it. What is the amount of kinetic energy in an electron here? As I remember, I have proved it as QE2. So this is the kinetic energy of an electron. Check the previous statements. This is the energy in a photon. So what is the relationship between them there? Not all the kinetic energy converted is given to the photon, but only a part of this energy is given to the photon. So therefore, not QE2. QE2 multiplied by a certain constant equals HF. Normally, the value of K is less than 1. So this is the relationship, right? As we know, the Planck's constant, value of the Planck's constant, as we know Q, E2 and K, the frequency of the X-ray can be calculated from this equation. That's what we are going to write next. So next star point. The amount of energy in a photon, the amount of energy in a photon, the amount of energy in a photon can be found by the following equation. The amount of energy in a photon can be found by the following equation. Leave a line and write energy equals HF. Energy equals HF. This H is Planck's constant. H is Planck's constant. F is frequency of the wave. F is frequency of the wave. Please write. H is Planck's constant, F is frequency of the wave. The amount of energy in a photon is given by this equation. But amount of energy in the photon is equal to a fraction of the kinetic energy of the collided electron. Got it? So star point and write, but below this equation, please write star point, but the amount of the energy in a photon, but the amount of energy in a photon, but the amount of energy in a photon is equal to a fraction of the kinetic energy of an electron. But the amount of energy in a photon is equal to a fraction, of kinetic energy of an electron. The amount of energy in a photon is equal to a fraction of kinetic energy in an electron. So leave a line and write, therefore K times QE2 equals HF. K times QE2 equals HF. QE2 is KE, kinetic energy of an electron of an electron. K is a constant. Normally, the value of the constant K is less than 1, right? So as you know K, Q, E2 and H, then you can find the frequency of the wave. That's the magic. And that's all the theory related to the X-ray tube. Now we are able to discuss a past paper question. I have discussed all the theory. If you have any doubt, you can ask before we start the discussion of a past paper question. Right? Check the note. If you have any doubt, please ask. Okay, did you write note? Shall we go to the past paper here? Shall we start the discussion of the past paper question?
Okay, sir.
Right. Let me show you the question. Right. So this is the tube that we are going to force for the students in July. In July, I'm going to force this tube. End of July, I'll post. Right. So this tube will give all the past paper questions given from matter and radiation. The first past paper question given in matter and radiation was given in 1998 A-level paper. That's the first matter and radiation question given in Sri Lanka. So I'm not going to discuss 98. I'm not going to discuss 99. Yeah, I'm going to discuss 2000 AL matter and radiation question. Look at the figure here. So what is this arrangement here? Somebody please tell me what kind of an arrangement is this? Namai? It is. What is this arrangement here? You know it. You have learned it now.
Used to generate X-rays.
Yeah, it is X-ray tube. But what they have done here, in our figure, we have kept the heating coil at our left-hand side. Target metal was kept at our right-hand side. So what they have done here, they have changed right-hand side, left-hand side. Am I right?
Yes, sir.
And they have, what about the metal simple area? They have changed A and B also. Our B, they are A. Our A, they are B. And they have used capital letters. That's the difference. And one of the things that we had in our arrangement is missing in this. What is it there? You have written the note. Compare the figure that I have given for the X-ray tube and compare the figure given in this question. What is the missing point there? Missing gadget. Sorry, I didn't hear you.
The liquid tube.
The liquid tube is missing. The cooling tube, which is connected to the target metal, is missing. And another thing is missing. What is it?
Another metal, sir.
The metal simple A, dear, the metal which used to generate sorry. The metal tube that we used to generate free electrons, this one, see, this is missing, right? Simple A metal is missing. Am I right, dear? Okay.
Yes, sir.
And the other thing is the voltages, they have, we use the term, here we use the letter E1 for the for this voltage, and here we use E2. They have used P1, P2. Am I right, dear?
Yes, sir.
Electrons, the electrons which are generated here are negative charges. The negative charges should travel from simple A. According to our notations, this is simple B. So if I wish to send negative charges to metal A, so actually according to our notation, it should be simple B. If I want to move the electrons to here, what should be the potential here, dear? Positive or negative?
Positive, sir.
Positive. So this should be positive. And what should be this, dear? This should be negative. So then negative repel, negative electrons attracted to positive charge. So then only electrons will be moved. To have this positive, what should be the polarity of X, dear? What should be the potential of X, dear, to make this positive? P1 is a battery. So which terminal is the positive?
Positive.
It should be
Yes.
positive.
So X should be the positive terminal. Then what about Y, dear?
Negative terminal.
Y should be negative terminal. So it means there should be a battery like this. P is a battery like this. Negative terminal connected to Y and positive terminal connected to X. Arrangement? Yes, dear. Any doubt? Sorry? Okay. If you want, please take a screenshot because I can't keep it like this, and we don't have time to draw this one. So if you want, please take a screenshot. Okay, dear? Right. I'm going to erase everything. If you want, please take a screenshot.
Okay, sir.
I have taken a screenshot for you because if you have forgotten it, this will be help. Right. Then let's go to the questions. Let's go to the questions. Right. Can somebody read Roman number 1? So this is the X-ray tube. Somebody please read Roman number 1.
Name components indicated by A.
A and B. So what is A, dear? What's the thing that they have marked as A?
Target metal.
Yeah, please write A equals Roman number 1. Please write 2000 AL matter and radiation is equation. Then please write Roman number 1, the first equation. A equals target metal. 2000, write the heading as 2000 AL Matan radiation is equation. Simple Roman number 1, capital A equals the target metal. Target metal. Then what is B, dear? Capital B, somebody?
The heating coil.
Yeah, please write capital B equals heating coil. Capital B equals heating coil. Now read Roman number 2. Somebody read Roman number 2, dear.
Why does the X-ray tube have to be evacuated?
The term evacuated used to say that tube is a vacuum. So this side, there is nothing inside this tube. It is said to be a vacuum. Why do we create a vacuum in the tube, dear? Somebody please tell me the reason. I have given it as a star point. Why
So-
do we want a vacuum? Yes, dear?
So electrons will not collide with. So
To
electrons will
avoid
not
the
collide with the
collisions.
other particles inside the glass tube.
Very good, very good. To avoid the collisions between the electrons and the particles in the tube. So there should not be any particles in the tube. If electrons collide with the particles in the tube, kinetic energy of the electrons will be wasted. So then energy of X-rays will be reduced. So then the penetration power will be reduced. So please write Roman number 2. Roman number 2, please write to have a higher penetration power for the X-rays. To have a higher penetration power for the X-rays. To have a higher penetration power for the X-rays, comma, the tube is evacuated. To have a higher penetration power for X-rays, comma, the tube is evacuated. The tube is evacuated. Okay, dear? Okay. But if you want any further explanation, but that's the answer for the
Okay,
exam.
sir.
That's the answer for the exam. So if you want, please write this small note below the answer. If you want, please write the as a note below the answer. But no need write this part in the examination. So please write, if there are particles in the tube, if there are particles in the tube, comma, electrons will collide with them. If there are particles in the tube, comma, the electrons will collide with them. If there are particles in the tube, the electrons will collide with them. Then the kinetic energy of the electrons is wasted. Then the kinetic energy of the electrons, comma, is wasted. The kinetic energy of the electrons, comma, is wasted. Full stop. Due to the lower kinetic energy of the electrons, due to the lower kinetic energy of the electrons, due to the lower kinetic energy of the electrons, comma, X-rays will have lower energy. X-rays will have lower energy. X-rays will have lower energy. Right? So low energy X-rays mean low penetration power. Who would like if I repeat the note? Anybody in the class? Right. If so, somebody please read question number 3, Roman number 3. Read.
What is the use of voltage supply P?
Right. Why do we use this P2 voltage supply here? To generate heat energy in the heating coil. Then electrons are emitted from the heating coil. Got it here? What is the use of P2 voltage supply? To generate heat energy in the heating coil. Then the heating coil will generate electrons. So please write Roman number 3. P2 voltage is used. P2 voltage is used to generate heat energy in the coil. P2 voltage supply is used to generate heat energy in the heating coil. P2 voltage is used to generate heat energy in the heating coil. Full stop. Then electrons are emitted from the heating coil. Then electrons are emitted from the heating coil. Then electrons are emitted from the heating coil. Okay, dear? Can somebody read the answer for Roman number 3? Somebody please read the answer for Roman number 3.
P2 voltage supply is used to generate heat energy in the heating coil. Then electrons are generated or emitted from the electric coil.
Then the electrons are emitted from the heating coil. Then the electrons are emitted from the heating coil. Now let's go to Roman number 4. Right? Can somebody read Roman number 4, dear? Somebody in the class?
What is the polarity of the terminal X of the voltage supply P1?
Right. So you should know that electron should be moved from B to A. So therefore A should be positive.
Polarity.
Now A, that should be the positive terminal. And Y should be the negative terminal. So please write X should be positive. X should be the positive terminal. Next line, Y should be the negative terminal. X should be positive terminal. Next line, Y should be negative terminal. Are you okay, dear? Then only electrons are moved from B to A. Then only electrons will travel from, electrons are pushed by the negative terminal, attracted by the positive terminal. So electrons will be moved from B to A when X is kept as the positive terminal and Y is kept as the negative terminal. Okay, dear? Is it clear or may I explain again? Right, now let's go to Roman number 5. Roman number 5. What factor determines the emission of X-ray photons? What factor determines the rate of emission? The rate of emission of X-ray photons. Rate of emission means the number of X-ray photons generated per second. That's the meaning. Rate of emission of X-ray photons means the number of photons generated per second. The number of X-ray photons generated per second depends on the number of electrons generated. Number of electrons generated. Right? So number of electrons generated depends on P2 voltage. If P2 is larger amount of electrons are generated. When large amount of electrons are generated, large amounts of electron will collide with A, then large amount of X-ray photons are emitted. So if I want to increase the number of X-ray photons emitted, I should increase the P2 voltage. So therefore, what is the answer for Roman number 5 here? What factor determines the rate of emission of X-rays? So please write P2 voltage. Roman number 5, answer is P2 voltage. P2 voltage. Is it clear here? P2 voltage.
Sir,
Any
can
doubts?
you explain it again like you did before?
I said this.
Sir,
If-
can you explain it again like you did before?
Yeah, if P2 is larger, more current will flow through the heating coil. When more current flows through the heating coil, more heat energy is generated. When more heat energy is generated, more electrons are emitted from the heating coil. When more electrons are emitted, more electrons will travel to A. More electrons will collide with A. Then more X-ray photons are generated. More X-ray photons mean more X-rays are generated. So number of X-ray photons will be larger when more electrons collide. So if I want to have more electrons, I should increase the P2 voltage. Therefore, rate of emission of X-ray photons depends on P2 voltage supply. Is it clear or not?
Yes, sir. It's clear. Thank you.
Right. Roman number 6. What factor determines the X-ray photons? Energy of X-ray photons, dear? If I want to have more energy for the X-ray photons, what do you think about the energy of a kinetic energy of electrons, dear? Somebody?
Should be right. Should be right. Not sure.
To have more energy for X-ray photons, we want more kinetic energy. To have more kinetic energy, the P1 voltage should be larger. When P1 is larger, there will be more kinetic energy. So therefore, answer for the Roman number 6 is P1 voltage supply. Right. I'll explain the rest of the questions next week, but I'll send you a photo of this question. So you should write these questions at home. Okay, dear. I'll discuss the rest of the questions next week. Right. Even I'll explain this Roman number 6 also. So I think that's enough for today. Is it enough for today, dear? Hello? Lamai? Okay then. See you.
Okay, sir.
See you. Good night. Bye.
Good night, sir. Thank you, sir.
Thank you, sir. Good night, sir.
Thank